just because P is orthogonal then. Here is an example. If we have 2 by 2 symmetric matrix, then do you remember the characteristic polynomial for 2 by 2 symmetric matrix is, I have lambda now right here. So it's lambda square. What's next? Do you remember the coefficients for 2 by 2 matrix A? So this characteristic polynomial. So minus trace A plus determinant A. Yes? Do you remember?
Oh, yes.
So you can solve this quadratic equation. We have the formula for the roots. These are, do you remember, if you have x squared plus ax plus b, then the roots are, yes, the eta or just formula, it's minus a over 2 plus minus square root of the discriminant. And discriminant is, so if we have lambda squared plus a lambda plus b, then the solutions are minus a over 2 plus minus square root of discriminant over 2 over 4. So I just take 1/2 from, and the discriminant is a squared minus 4b. Okay. Now, what we do here, we have A is the trace, and B is the determinant. So we can calculate everything here. So the discriminant becomes, so determinant is, if matrix is A, B, C, D, the determinant is AD minus CB. This is, okay, I don't need the determinant, or do I? Okay, so this minus 4b. And A is the trace, so it's A plus D. So I have A plus D squared, this is for A squared, minus 4 times the determinant, which is AD minus BC.